In this demo, we'll look at what can be done with an existing CICS COBOL application once it has been API enabled with z/OS Connect, and how we can use those APIs along with data from other z/OS Connect based API calls to rapidly transform our initial application to add features and functions using open source and cloud native technologies. The specific scenario we'll look at assumes an existing CICS COBOL inventory application which needs to change because our business is changing. Our business has grown and we now have employees in warehouse locations across the world, so we need to update our inventory system to add information which will allow us to ship items in our inventory from those multiple warehouse locations to our employees across the globe. Lucky for us, the additional data we need resides on our z/OS system in both a DB2 database as well as in a vSAM file which we can access as a virtual table using IBM Data Virtualization Manager. So what we're going to do is use z/OS Connect as a REST API entry point on our mainframe to provide a common and consistent access pattern using REST JSON to pull together data from those three different mainframe data sources without the client developer having to understand the implementation details of those backend systems. This will let our developers use common, popular open source frameworks and tooling to create a new application that uses those mainframe-based applications and data sources in the same way they use any other REST JSON-based APIs. So I'll look at a Node.js application that pulls in data from those three mainframe-based APIs, as well as pull in additional data from a local JSON database that I've packaged with the Node.js application. In the second part of the demo, we'll look at the different deployment options we have once we've built this new Node.js inventory application that pulls in all this data using z/OS Connect. So there are two paths we could follow. One is this more traditional path of defining a server, installing and configuring the middleware, then installing and configuring the application. For a Node.js application, there are several options for this traditional server approach. We could run this application on a local workstation, on a Linux server somewhere, including Linux on Z. We can run Node.js natively now on z/OS, and we can also run this Node application on many cloud environments, including the IBM Cloud. But the approach I'm going to take is this other container-based model in which we'll create a Docker container with the runtime, the application, as well as its required configuration, all packaged together in a Docker container image. So why go through this extra step of creating a container? Well, containers provide a lot of benefits. They really promote portability and flexibility. Once you've packaged your application into a container, it becomes deployable in lots of different ways, as we'll see. It really promotes consistency by packaging the runtime, the application, and all its dependencies and configurations in a single container. It really prevents the "it works on my machine" kinds of problems that we see. So moving things from dev to test to prod becomes much more seamless and less error prone, which leads to the adoptions of some of these DevOps, CI/CD, shift left type practices that we're seeing. And then there's the whole efficiency aspect of running a container, which is essentially a process versus an entire operating system for an application. So this leads to improvements in speed, size, and resource utilization. So we'll expand on the approach we're going to follow later on, but as a preview, we're going to start by creating a Docker container with our application and running it on our local workstation. Then we'll take that same container image, push it up to Docker Hub, so that we can pull it down into the IBM Cloud and run it on a Kubernetes Red Hat OpenShift container platform environment. And finally then, we'll run this container natively on a z/OS system using the new z/OS container extensions capability introduced in z/OS 2.4. So hopefully by the end of the demo, you'll see how we've greatly improved our flexibility, both from a developer standpoint with the use of z/OS Connect to provide a consistent access pattern into our mainframes using these REST APIs, as well as improving our flexibility from a runtime standpoint with the use of Docker containers and the way that lets us push those container images to lots of different environments. So we'll start the demo by looking at our initial inventory application, which I said is a CICS COBOL application that keeps track of our inventory are a set of mobile devices that we have in stock. It's a fairly simple application to use with just a couple of functions that we'll need to use in our REST APIs. The first function is the ability to list everything, list all the items in our catalog, which if we do that, you can see we have 15 separate items or devices that we keep track of. And if we want to get details on a specific item, we can drill down into an individual item. So here's item number 30. If I want to get details, I put a slash next to the order column. And here you can see device 30 is a Droid 2 Global by Motorola. Costs $759, and I have 5 of those in stock. Now, if I was a power user, I could go back here in my application and go right to item number 30 and get that same data. So as you can see, it's a pretty bare bones application with just the minimum amount of details about each device in our inventory. And there are 2 primary functions then that we'll end up using as REST APIs in our Node.js application. The function of listing the entire catalog, and then the ability to get details about a specific item if we pass in and know the specific item ID. Now we'll look at the REST APIs we've defined using z/OS Connect, which will access both the CICS application as well as the APIs we've defined to pull in the additional data we'll need from DB2 and vSAM file that will add what we'll need to ship these devices. As I said earlier, I'm not going to detail the steps that you'll need that we use to create these APIs and deploy them with z/OS Connect, because we have lots of other resources that can help with that. We have web articles, there are YouTube videos, there's even a trial system you can get access to that lets you go through that process yourself. So I'll point you to some of those resources later. So instead, what I'm going to do is assume that we already have done that. We've created these APIs, deployed those to z/OS Connect. Now we want to start using those. So the first thing, as I'm going to build an application that would use an API, I need to understand how to make use of that API. So we can do that through the use of a Swagger definition. So z/OS Connect, we have a couple of different ways that you can get access to the Swagger definition. One is through using a browser. So you can point your browser to your z/OS Connect host and port and query on z/OS Connect APIs, which you'll get back a list of APIs that are defined. And in this particular server, you can see that we have 2 APIs, one called Catalog and one called Catalog Device Dimensions. So if we drill down into each of these APIs, we can get the actual Swagger definition for those APIs. So this API, this set of APIs, calls my CICS application. So you can see I have 2 different API paths set up. One that does a query on items, and if we scroll down here into the parameters section, you can see that it takes a query parameter called start item ID. So this then will be the API I call to get back a list or an array of all the items in my database behind my CICS application. The next API is where I'm calling in the items API or calling the items URL with a specific item ID, which gets passed in as a path parameter. You can see item ID here is a path parameter. So when I get that, when I call that, I get back a single item, and we can see that by looking at the response. So if we go down here into the get inquire single response, and I scroll down, you can see that it sends back an object that has some properties on it, which are shown here. So all of the individual properties about that device ID that we just looked at using our Kix application. The other response for the inquire on the entire catalog will send me back an array at some point here. You can see that I have a cat item array, so I have an array of items that get sent back, which has those same set of properties. So if I want to do a query on the entire catalog, I call one API. If I just want to query on a single item, I call the other API. So that's one way of looking at the APIs, is through the Swagger definition. But what I also want to show you is the Swagger UI tool. So the Swagger UI tool is an open source tool that we package with the API toolkit that installs into the z/OS Connect or to the z/OS Explorer, any of our other Eclipse-based products that we have that you can work with z/OS Connect. And using the Swagger UI tool, you can not only see the definitions, in fact, I should slow down here. So here are the different APIs that I have defined. So if I open that catalog API in the Swagger UI tool, that's what I have here. So by looking at this, I can not only see what APIs are defined, so I can see that I have my query on the entire catalog API, query on a specific item API. I can see the format of the response that I'll get back, a little bit easier to read than that Swagger doc, and then I can also test this API. So if I want to call this API with item ID 30, I can click try it out, and it will send a request to this URL based on the Swagger definition, and then I get back the data from my CICS application. So this is my JSON response object I got back from z/OS Connect, which called my CICS application. So that's one of my CICS APIs. The other one, as I said, was where we're querying the entire database, and that takes the start ID or the item ID that we want to start with. So we'll start with item ID 10. If we click try it out, I should get back an array of items that have information about each of the items in my device ID database. So those are my two CICS based APIs that we'll use later. The other APIs I've defined are my DB2 based API, which is this one here, device dimensions. And if I open this up, I have the same basic process to test these APIs. I really have no idea what is behind this, if it's a DB2 database, a CICS system, an IMS system. Same set of tooling. You can see that when I make that call, I get back a JSON response object that has details about item ID 30 or device ID 30. And then this other API, this is my vSAM file API, which we're front-ending with DVM or Data Virtualization Manager. And if I look at the operations here, I have a single get method that I can call, item shipping. And notice this API has security turned on, so it does require some type of authorization parameter. So I have my authorization header defined out here. Let me copy that. And if I pop back here and put that in there and go to item ID 30, I should get back a JSON formatted object that we see here that has details about where that device, what warehouse location that device is in, so that if I'm trying to ship it, I'll know kind of how to calculate my shipping details. So those are the three APIs, or three sets of APIs we'll use in our Node application. We'll also then use a REST API that calls a local JSON database, but as you'll see, it uses the exact same process and tooling to make those calls. Okay, so let's jump over here and start looking at that Node application. So this is my application here. It's a fairly simple application. In fact, I don't pretend to be a Node.js expert. This is the first Node app I wrote besides Hello World, so I think that's maybe a testament to how easy it is to build applications using some of these open source tools and frameworks. If you're not familiar with Node, it has been around for about 10 years. It's a way of running JavaScript code on the server. You know, prior to that, JavaScript had always been strictly a browser-based language. And with Node.js, now you can have those same JavaScript developers write server-side code. So I'm not going to try to explain how the entire application works. Instead, I want to focus on where in the application I'm actually making those API calls to our backend applications. So we'll start with our item list component here. So this is the API call that we use to get the entire list of our inventory, right? So this calls our CICS API, the Inquire Catalog API. And if we pop back over to our Swagger definitions for that API, you can see it right here. This is where we're calling items. This is the URL I query, where I pass in a query parameter called start item ID, and I get back an array of items, right? So for every item in my Kix inventory, I'll get back an element in the array. So if we look at this HTTP call, so one of the advantages of using some of these open source frameworks is they have lots of helper services and methods. So this HTTP is a helper service from Angular. That's one of the frameworks I'm using. And it has a get convenience method that lets you very easily make an HTTP GET call to a certain endpoint, and that endpoint I took just straight from my Swagger definition, and then on my response I could kind of walk the tree down in my JSON response document to figure out where to set my response object. So that's kind of as far into the details as I want to get on this API call. So now what I want to do though is look at where I think is a more interesting set of calls is my list component. So my list component, or my detail component, pardon me. So my detail component, this is where I'm getting the actual details for my for each individual item. So the first HTTP call here is where I'm doing a GET to an individual item. So again, I'm just going to pop back to my JSON file or my Swagger definition and look at the GET call for an individual item ID, right? So this is where I'm passing in an item on my query as a path parameter on my HTTP URL, and I get back a single response object, a single JSON object that has details about that item. So in my code, I'm using the HTTP GET. I just drop in that URL where I'm getting the item ID being passed into me in this component, and then on the response, I set that to an object that I can use later. So that's my KICS call. If we look at the next HTTP GET call, this is where I'm calling my vsam file through my DVM connector. I use the exact same type of call. It's an HTTP GET call. I put in my URL where I'm passing in the item ID. Notice I do have a little bit of a difference here where I'm passing in an authorization header on the request. The reason is because if you recall, if we go back to that Swagger definition for it, and we look at my item shipping call that we made, remember this was a required parameter, authorization, because they have security turned on for this API. So you can see here that I have a request header, an authorization header passed in on my API call. So that's really the difference here, is because I have security turned on. I need to provide an authorization header. Everything else is about the same. I set the response to an object that I will use later. The DB2 call looks identical to my KICS call. I use the HTTP GET, passing in a particular URL, and I set the response to an object that I will use later. And then finally, this is how we're going to do our details call, or we're going to pull in data from a location other than the mainframe. Notice I use the exact same HTTP GET method call, but instead of passing in a URL, an HTTP URL, I can just point to a file in my local application. So notice I have an items directory here that has a bunch of item JSON files, right? So that's what I'm representing here. And each of these item JSON files then has additional details that I can pull from and add to my application. So that is essentially it. Hopefully you can see how the simplicity and the consistency of making API calls using these REST endpoints is really simplifies things from a developer's perspective. I don't need to understand anything about the mainframe to make use of these API calls, and I can use tooling and frameworks that I'm very familiar with. So let's run this and actually take a look at the application. So we'll start it using the npm start command, which should let me go out to a browser now and go to my local host and port 3000, which is the default location for an Express server. That's one of the frameworks I'm using. And you can see here that I'm pulling back data from my KICS application. So this is that Inquire Catalog API call where I'm doing a list of everything in my inventory. So all of the data here is all coming from CICS. This description, the price, the quantity in stock is coming from CICS. Now notice I don't have the shipping details here. So for that I need to go into the details page by clicking on one of the devices, and you can see this is where I'm pulling all of those API calls, all the data from all those calls together in this page here. So these fields, the availability fields, are coming from my KICS COBOL application. The ships from fields are coming from my warehouse inventory in my vsam file that we're calling through my DVM based API. And then the size and weight, the dimensions about each device, is coming from my DB2 database. Everything else you see here, all these other additional details, all these images, this expanded description, are all coming from those local vsam or those local JSON files that I made use of with my with that HTTP GET call. So hopefully you can see how this this new REST API way of accessing your mainframe data really simplifies things. So right now we're running this as a standalone Node.js application. The next thing we'll do is look at containerizing this and running it on some of the different container platforms that we have available. Okay, so before we start doing this, start building the containers, I just want to start or jump back to our diagram, our initial diagram that kind of showed what we were doing here. So we looked at what we can do with z/OS Connect, how that gives us REST API access into all this great mainframe stuff, how we can use open source tools and techniques such as a Node.js application. So now we're kind of at this point where we need to decide, are we going to follow the traditional non-container approach where we install our operating system, our middleware, we configure our application, we start our server. That's kind of how we've always pushed applications out. But actually what I want to do is follow the container approach, where we're going to build and define a Docker container that has all of that stuff preset in our container runtime. This really gives us a lot of benefits. It really leads to application and runtime portability. Consistency is much improved when you're using containers. You can more quickly and rapidly do your DevOps processing, right? CI/CD types of things, resource utilization. There's just a lot of benefits to using containers. So let's jump to this next diagram I have here, where we're going to kind of start at this application, at this Node app, and look at that container flow. So first thing we'll do is we'll build the container. So Docker has a build command to build the Docker container. Then we'll run it locally. So that's a very easy, quick thing to do. More typical, however, kind of the next step is you're going to want to push that up to some type of image registry. So Docker Hub has a publicly available image registry. Anybody can have an account. So we'll push our container up there. And from there, we could do Docker pulls into lots of different places. We could pull it to any Linux environment running on a Intel system, a Power system, a Z system. So Linux on Z, this works great. We could pull that image into a Red Hat OpenShift container platform environment. So if you're into Kubernetes clustering, this is a great way of doing that and running your containers there. You could also pull those into a ZCX or z/OS container extensions environment and run your containers as a z/OS in a z/OS address space natively. Also, kind of the third path out of this container is to save that Docker container to a tar file. So maybe your backend system, your z/OS system, you don't want to have hooked up to the internet. You want to have some type of control over that. So you can still do FTPs into that system and load those containers via that. So these are kind of we'll follow three separate approaches here. We will go through this local build here. We'll run that container locally. We'll push our container up to Docker Hub and then run it in an OpenShift environment. And then we'll save our container to a tar file, FTP it up to our ZCX system, and run it there. So let's start with that local approach. So let me go back to my server here. We'll stop my node system. And what we'll need to do is run a Docker build command. So a Docker build basically takes your Docker file. This is where you define to Docker how you want to build your container. So here's the Docker file for my application. I'm going to start with the base image. So I'm going to use the latest node image that's available. So this will pull it down from my Docker registry, which in my case is Docker Hub. So I'll get the latest node image from Docker Hub. I'll do some configuration in the container, set some variables. I'll copy my application my package.json file up into the container. I'm going to install it, copy my source code, expose my port, and start the container. So to run that is just as I said, it's a Docker build command. We're going to want to tag it, so we'll want to give it a name. I'll call it eGUI demo maybe. And we need to point to that Docker file, and we need to give it the directory that contains the application, which is my current directory. So if I run this, it should run fairly quickly, and at the end of this, I should have a working container. So I'll have a couple of warning messages. I'm using some deprecated applications or frameworks, open source packages in my application. Somebody's looking for some funding. And there we go. So now if I do a Docker images command, I should see, if I make this terminal a little bigger, I should see that I have an eGUI demo image right here that was just built 6 seconds ago. So to run that container is just as easy as running the docker run command. I do need to give it a couple of options. I need to tell it what port I want to expose to the outside world. So remember up here we said we're going to expose port 3000 from our application. So this is how then I expose that outside the container. And I'm going to run in disconnected mode, and then I can just simply say eGUI-demo, give it the container name. And that is it. So if I pop back to my browser, I should be able to go out here to localhost 3000, and I should see the exact same application that we looked at earlier, that Node.js application. Now it's running inside of a container. Pretty easy. Okay, let's go back to our picture. So the next thing we're going to do is, so we did this path, right? We have this working container that we ran here. The next thing we're going to do is we're going to push it up to Docker Hub and run it in OpenShift. So to do that, we'll go back to our terminal, and to do a Docker push is, now since this is a public registry, I'm going to want to tag it with a special name so that I know it's my image. So I'm going to do a Docker tag command, and it is the eGUI demo image. I'm going to call it Bill Keller /eGUI/demo. So just putting some context around it so that I can tell that it's mine. So now if I do a Docker images, I should see a Bill Keller eGUI demo image right here, and I can then push that up. Now I do need to be logged into Docker Hub, so I've already done that. But once you're logged into Docker Hub, you do a Docker push. Let's see, where is that? Docker push. I think it's just Bill Keller /eGUI demo. So this will push that up to Docker Hub and make it available to any other back-end Docker systems that have access to Docker Hub. All right, there we go. So now let's jump over to our, so here's where we are. All right, we have our image up here. Now we're going to look at OpenShift and see how we can integrate and run that OpenShift, or that Docker container that's going to use our z/OS resources in OpenShift. So I want to go to my OpenShift topology page. So this is my main OpenShift console running out here, and this is running in IBM Cloud. This could be running on premises. This could be running on one of the other cloud providers that are out there. And I have different ways of deploying, right? So I can deploy source code from Git. If I had a local catalog of applications, I could build the image using my Docker file here. But I am just going to go ahead and pull that container image that we already had up there. So the Docker Hub image registry is available to my OpenShift cluster here. So I'm going to just go out and look for the one I just sent up there. And if I search for it, it should see that it found it. It gives me a message saying that I'm running this as root. That's not a best practice. That's all right. And we'll go ahead and create our container here. So we're going to wait until this turns dark blue. That indicates that our container, or that our application and deployment is running, and then we should be able to hit it. Okay, so it looks like we have a blue ring around our application. If we look at it and go to the overview, we should see an active status, which we do right down here. So we should be ready to hit it. So let's, if we click on this little icon here, this opens the application in a new URL, and there we go. We have that same application that just 5 minutes ago, maybe 10 minutes ago, we were running locally as a Node application on our own workstation. We packaged it as a container, pushed it up to Docker Hub, imported it into our Red Hat OpenShift cluster Kubernetes environment in IBM Cloud, and we're running it up there now. And keep in mind, this is accessing the mainframe. We're still getting, every time I run this, we're getting that application to call CICS, to call DB2, or to call vSAM through DVM, and to call DB2. Alright, so let's go back to our picture. So we've kind of run through this option, Next thing we're going to do is go down this path where we're going to create a tar file, FTP it into our ZCX environment, and run it there. So I need to go back to my workstation here. And here what we need to do, since our end runtime is not going to be an Intel-based system, it's going to be z/OS hardware, or not ZOL, it is z/OS, but it's Z hardware, right? So we need the 390X S390 instruction set. So what we can do then is, through a single change, let me open up both Docker files. So this is the Docker file I just used where I'm pulling from kind of the base node image. There also is available out in Docker Hub a bunch of S390X images. So as you might guess, those are S390, Linux on Z images that were built specifically for the Z hardware instruction set. So there's images for node applications, Python, there's OSs, there's Ubuntu, there's Fedora, there's databases, there's MongoDB, Redis, Postgres, you name it. I think there's over 250 separate S390X labeled images that you can use as your base image. So we're just going to use that exact same image or the exact same set of commands, the same way of configuring my container, with the only difference being that I'm doing this for the 390 version, the 390X version of Node. So I'll run that same docker build command, and we'll tag it as kind of the nomenclature is to use S390X, and then we'll tag it as eGUI demo. And the Docker file we'll use is my 390X Docker file, and we'll point to my current directory. So that ran really quick because I've already run this recently, and it, Docker does a lot with caching, so if you're not making a lot of changes, it doesn't take a lot to do new build. So there we go, we have a new image. So if we do a docker images command, I should see my new S390X eGUI demo right here. Alright, so as I said, what we're going to do now is follow that path of creating a tar file. So maybe the Z system we're going to load it into does not have internet access, but we can FTP to it. So we're going to do a docker save, and we'll take our S390X eGUI demo image, and we'll give it an output file. I'll call it s390x.eguidemo.tar, and I think that's all I need. Okay, so that should have done it. Now if we do an ls -la, we should see that new file out there, s390x demo. It is big, it's over a gig. So the next step is to FTP this into my ZCX system. So I'm going to go ahead and do that and catch up with you when we have that ready to go. Okay, I'm back. I FTP'd that gigabyte file up to my ZCX instance, and you probably noticed my desktop has changed. I'm running a Linux system as a virtual machine on my Mac desktop that is running ZD&T, Z Development and Test, which is a really cool way of running your own z/OS instance on your workstation or on a non-Z piece of hardware. So that's everything from here on out. We'll be doing that. So what I'm looking at here is my z/OS system. It's actually running as a Linux process in a VM that's running on my Mac system. So there's a lot of virtualization going on here. But just to give you a quick rundown of ZCX, we're looking at ZCX right here. It's an address space that you configure and define. As I said, it's a way of running containers, Docker containers, natively on z/OS. It's a big address space. You can see I'm using kind of the minimum amount of memory required is 2 gigs, so it's big, but it runs really well. So what I've done then is out here I've telnetted into that system. So we're kind of looking at the same address space from two different perspectives. Here we're looking at it outside, we're just looking at it from the z/OS perspective. Here's where I've actually telnetted or SSH'd into that system. And once we're in here, it works very similar to any Docker-based Linux system or Linux system that has Docker installed. So here you can see if I do an ls, I have that S390X eGUI demo tar file that I just created and uploaded into my ZCX instance. The next thing we'll do is we want to load this into an image, right? So we have a tar file. We need to import that into my Docker image registry, and I do that by running the docker load command. So docker load. You give it the less than sign, and I'm just going to do some cut and paste here. So we'll copy that and paste it, and we'll let that run. Now this is a big file, so this will take a little bit. Okay, so that loaded. So through the magic of video editing, it looked like it just took a second or two, but it took a couple of minutes. Like I say, this is running on a Mac system with a VM, with a Linux GAS, which is running z/OS, which is running my Linux with Docker. So there's a lot of virtualization in there. Running this natively on z/OS would be a lot faster. So I should be able to do a docker images command and see that new image. And here it is, right here, Docker S390X eGUI demo. So that's what we just loaded into our system, and I can run it using the exact same docker run command we used on our desktop. We'll set up the port 3000, make sure that that is exposed to the outside world. We'll run in disconnected mode, and we'll give it the image name, S390X eGUI demo. And we'll let that start. Okay, so now we should be able to test it. So let me pull up my browser on my Linux GAST, and we will try to hit that port. So that is my z/OS system is 10.1.1.4, that's the IP address, and we expose port 3000, and we should, fingers crossed, be able to load our same application. So there it is, the exact same code we wrote and ran on our Mac system is running in a container on z/OS using z/OS container extensions. So let's just review what we did with our demo. Let me pop back to our picture here. We started with that Kix Cobalt inventory application that we needed to update because our business has grown. We needed to add information from our application so that we can ship these devices. We needed shipping details about the device. We needed to add warehouse location data. We did that all by using REST API technology with z/OS Connect. So that we could take advantage of some of the open source frameworks and tools that make it quick and easy to develop cloud native Node.js applications like we did. Then we made the switch and we looked at the different runtimes, right? So we packaged our application as a container, we ran it locally on the workstation, and we ran it up in the cloud, and then we ran it on our z/OS using z/OS container extensions.